Hey, we spent a lot of time talking about triangles already. We're going to take a little bit of a break of proofs in this section. I don't think any of my examples are actually proofs, so which is kind of nice. So we're going to look specifically at some special case triangles. We'll talk a little bit more about isosceles triangles, and then we'll also do equilateral and equiangular triangles, which we find out are essentially one and the same. Okay, so section 4.6 notes from Google Classroom. Allows us to go through some stuff that we've already talked about, okay? Let's talk about isosceles triangles. We've talked about pieces and parts of isosceles triangles a little bit already, okay? So some vocab that we've seen before, the legs of an isosceles triangle are going to be the ones that are the congruent sides. So if I have an isosceles triangle here, let's say triangle ABC is isosceles, my legs would be the congruent sides, so B and C. And then my base is whatever my non-congruent side is, okay? So that would be BC at the bottom. In this case is going to be my base, okay? We say these things because not every isosceles triangle is oriented this way. Sometimes they look a little different depending upon where things are at, okay? Your vertex angle, which I believe you guys saw something in relation to this on the test, or the quiz rather, but your vertex angle is the angle that's connected to the two legs. So it'd be the one that's up here. So our vertex angle in this case would be angle A. All right, and then our base angle, that should be plural, but base angles are the angles that have the base as a side of that angle. So that would be down here for B and C. So we're going to say angle B and angle C. So I'm going to put two arcs there, okay? All right. So our first theorem says the following. In an isosceles triangle, you guys know you have two sides congruent. It turns out that you also have the base angles congruent as well too. So if two sides of a triangle are congruent to each other, then the angles opposite those sides are also congruent. So it is our base angles theorem, okay? Looks like everyone is here today. Yeah. All right. So if a triangle is isosceles, then we have not only two congruent sides, but base angles theorem tells me that these two angles would also be congruent as well too. And it's the base angles, so it's the angles that are actually connected to the base itself, okay? All right, so we're going to use that, and we're going to find measures of angles here for a couple of different examples, okay? It says find the values of x and y. So we've got x, we've got an angle that represents y, and then we have a 73-degree angle there. Which angle is easiest to find first, Braden?
Y.
Which is what?
73.
So those are my two base angles, angle T and angle U. So Braden is right. Y is going to be 73 degrees. Okay, cool. All right. Now we want to find what x is. What does that look like?
134. 146. 180 minus 146.
I like it. Where did 146 come from, Landon?
73.
Yeah, so if I show all the work, you guys are both right, but if I show all the work, it looks like this. We add together the three angles of the triangle, and then we set it equal to 180, okay? So then x plus, Landon said 146 equals 180. I take 146 away from both sides, and then I get x equals, Braden, what'd you say, 34?
Yeah.
So 34 degrees is what x is going to be, okay? All right, easy enough. If I know two sides of an angle are congruent, then I can say that my base angles are also going to be congruent. Okay? All right. So a couple theorems that go along with that. Okay, first of all, we have the converse of the base angles theorem. So if I know that my sides are congruent, then I can say my angles are congruent. The converse of that, or if I flip my if-then statement, would be if I know my angles are congruent, then I can say my sides congruent. Probably, are you all right?
Nope.
Stay with me, buddy. All right, so if two angles of a triangle are congruent, then the sides opposite those angles are also congruent, okay? All right, so that means in my picture here, if I know that angle B is congruent to angle C, then on top of that, I could then say that side AB would be congruent to side AC. So AB congruent to AC. So that works in both directions, okay? All right, and then we have something about a perpendicular bisector. That's actually something that I want to add to your reference sheet, your chapter 4 reference sheet. So I might actually have you guys pull that out at the end of the lecture so we can add that to it. But we've talked about like bisecting angles, bisecting segments, whatever. We've talked about perpendicular lines. But it's been a while since we've talked about something called a perpendicular bisector. Okay? So if you have something that you know is a perpendicular bisector, usually like a segment or a line or something like that, then what happens is it's a line that is perpendicular to a given segment and then also bisects that segment into two equal parts as well too. Okay, so if I do that of an isosceles triangle, then it says this: if a line bisects a vertex angle of an isosceles triangle, then the line is also perpendicular to the bisector of the base. So if you have an isosceles triangle and you know that the vertex angle is being bisected, then we can also assume that the base at the bottom is being cut into two equal parts with a right angle. Okay, so the pieces that we would get from that, we could say that angle BDA would be equal to angle CDA, and both of those are 90 degrees. And then we could also say that BD would be congruent to DC. So if that's like a given in a proof, that's a gold mine because you get two pieces of information which are really good from that. Okay. All right. And example 2 kind of follows along with that. So it says find the value of x. We've got a triangle there with a line cutting through the middle. We know that the outer triangle ABC is what type of triangle? Looks isosceles to me. Two of the sides are the same. So now I want to figure out what the measure of angle x is, or what the value of x would be. So what do you think?
30.
You said what?
30.
How'd you get that?
Because the perpendicular line means that those are 90, and then you know that the angle C is 51 because it's an isosceles triangle, so you got 51 plus 90, you get 141, and then you subtract that from 90.
Good. So then I could say 90 plus x plus 51 equals 180. So Braden just found expressions for each one of those using that theorem. And then combined them, x plus 141 equals 180. We take 141 away from both sides, and now we get x equals 39 degrees. Good job. All right, cool. Let's talk equilateral, equiangular. What does it mean if a triangle is equilateral?
Equal.
What's equal?
Equal sides.
All three sides are equal, right? We're going to have a theorem that says if all three sides are congruent, what would we expect to be the case about the angles? All three angles are congruent. Good. Not only are they all congruent, but they're all going to measure what? 60, because 180 divided into three equal parts is 60 degrees. Good. So if a triangle is equilateral, then it is equiangular. So the corollary to that would be if a triangle is equilateral, then the triangle is equiangular. If a triangle is equiangular, then the triangle is equilateral. So we can do it in either direction, okay? So if I know that all three sides are congruent, then I can say that all three angles are congruent. And then vice versa, if I know that all three angles are congruent, then I could say that all three sides would be congruent as well too. So then AB would be congruent to BC, which would be congruent to AC. And then, of course, I can use that to find a bunch of information for examples as well, too. Okay? All right, so let's do that. I think I did everything on there, right? Yeah. Okay. All right, so let's do these 4 examples. I'll tell you what, I'm going to give you 128 seconds to do example 3 and example 4. Set my timer. 128 seconds to do example 3 and example 4. We'll do the bottom 2 together. You guys can do 3 and 4. So look at what you've got in that picture. Try to figure out what type of triangle it is, and then see how you can relate those sides together.
13 minutes.
There you go. 2.13 minutes. Hope you guys didn't get too excited when you got that message from Mr. White this morning. I'm glad he did. I literally thought about posting Google Classroom, like, guys, give some safe stopping distance. Like, be safe in the snow. But there wasn't really any snow anyway, so. I know you guys get excited about snow days, but you have no idea how excited I get. I love a snow day. Where are we at? We got 36 seconds. Got to set up some sort of equation, right? All right, here we go. First one, example 3. What are your thoughts? What should we do? What do we know? Let's start there. What do we know about that triangle?
Equal.
What does that mean? Equal what?
Equal angle.
It's equiangular. So then we can assume that it's what? Equilateral. And we bring that up because the 5x, the 6x minus 5, those are expressions that go with the side lengths, okay? Well, so if it's equilateral, what can I do with those two expressions? Good, Julia. So 6x minus 5 equals 5x. We can set them equal to each other. In geometry, you always want to make sure you're not getting set equal happy, that you just see two things and set them equal to each other. You got to make sure that that is a true thing that you can do, all right? All right, I need to solve for x. Subtract 6x from both sides. Negative 5 equals 5 minus 6 is negative x. So we divide both sides by negative 1 to get x equals 5. All right, easy money. What about example 4? What do we know? It's equilateral. So because it's equilateral, what do I know about, what else do I know about it? Equiangular. And that's what it wants me to find as an angle measure.
180s.
So all those angles add up to 180, but what do you know about each angle, Dom?
60.
Yeah, because we take 180, we divide it by 3. So Dom just set 6x equal to 60. Divide both sides by 6, and I get x equals 10. Cool. So then the measure of that angle would be 60 degrees, as we would expect. All right, let's look at the ones on the bottom. These look like a little more complicated. All right, so it says find the value of v, which is this incredibly small letter at the vertex of angle x. And then we also want to find the measure of angle ZYW, okay? So let's find the measures of our angles in our picture here. All right, what do we know? What do you got? What do you think? Where's your brain at? Braden, where are we starting?
What I did is 54. Oh yeah, 180 minus 54, and then divide that answer by 2 to get the two angles W and Y.
I like it. The top triangle is an isosceles triangle. So Braden wants to start up there. So he's going to take 54 away from 180. And normally when we find the measure of a missing angle in a triangle, we have to know 2 of the 3. But Braden knows that the bottom 2 angles are going to be congruent to each other because it is isosceles. So 180 minus 54 gave you 126. So if I take 126 divided by 2, that gave Braden 63. So each one of these angles is 63 degrees. And they ask about one of them. The measure of angle ZYW is going to be 63 degrees. Cool. I still need to find what V is. That relates to my bottom triangle. I know Braden knows, but I want to hear from someone else. How am I going to find V in that bottom triangle? Kyle, what do you got, bud?
Angle, like, where the Y is.
Yeah.
It's equal to the 41 on the other side.
So also 41?
Yeah.
Okay, cool. Because that's an isosceles triangle as well, right?
Yeah.
All right.
You just, add those up and subtract it from 180.
Cool. So 41 and 41 is going to give me 82. And then 180 minus 82 gives me 98 degrees. So that's going to be V. Cool. All right. Another one. Talk to me. Braden's already done a lot of heavy lifting, so I'm gonna ice him. Angeline.
You can subtract 126 from 180 and find the value of the angle to the left of 126.
Cool. So I get 54.
Yeah, and then you can add 54 and 90 to get 144, and then subtract that from 180.
So 54, what does 54 give me? Are you saying right here is 54?
No,
Where are you saying?
like the angle to the left.
Oh, you're saying here.
Yeah.
I like it. Okay. So then 90 plus 54 gives me 144. And then 180 minus 144 is going to give you what?
36.
36. Okay, cool. So then that's what X is. 36 degrees. Cool. All right. Now I need to go back and I need to find a Y. What do you got for that, Angeline?
Oh, is it? Also 54, because
So I did 180 minus 126. That gave me 54, right?
yeah.
So if I think about it in terms of just this triangle, 126 taken away from 180 is 54. So you have 50.
54 divided by 2.
There it is. So if I take 54 and I cut it in half, because I have two angles that I know are congruent to each other, I get 27 degrees. Good. Yeah, so then that would be what my value is for Y. Okay. All right. How are we feeling? Attainable? Not bad? Easy lesson for a Monday morning? Sure. All right, cool. I'll give you a worksheet. Give you guys practice on that, and we'll do some chapter review stuff. And also, I'll check out your missing work that you have now. Now, before I just let you guys free, there are two proofs on here. Can I do one with you guys?
Yeah.
All right, cool. Am I gonna go to snow this? No. It'll be late by the time I get home. There's a decent amount of problems on here, but we go through these examples so quick.
That was the scariest thing you've ever done.
Kyle, I have a paper. You don't.
It's so hard to get in
Last time. Someone trying to cheat in Mr. Pacifica's class?
All right. What should we do?
The second one.
What's the first one? No, it's just finding your value of X for the vast majority of them.
Let's do
The
7.
two sides of the worksheet are really similar to each other. You guys will go through them really quick.
First proof.
What's the first one? I know what's the front side. The one that gives you angle 1 is congruent to angle 2?
Yeah.
Okay.
Yeah.
I like it. Let me pull up the worksheet.
Ryan, you got
Yeah.
the one he
I don't play Skylanders.
You wanna call over play Skylanders?
I've never played Skylanders.
You've never played Skylanders? You have.
Wait, should I play?
Yes, you should play Skylanders. It's a great game. Yeah.
How do you do that?
Is this the one you guys want to do first? Okay.
No, it's one.
All right, here we go. Angle 1, congruent to angle 2. Reason for that's given. All right, now look. This is like the easiest proof that we're going to do. I know that these two angles are congruent to each other, 1 and 2. I want to prove that AB is congruent to CB. So I really essentially just want to prove that these two triangles, or this triangle, is an isosceles triangle. I want to prove that those two sides are the same. So if I know angle 2 is congruent to angle 1, what else could I say about my angles? Tegan? I like it. Angle 3, congruent to angle 2. Give me a reason, my friend. Good. Vertical angle theorem. This should be a 1 right here. All right, cool. I know 1 is congruent to 2. I know 2 is congruent to 3. What can I say from that? One and 3 are congruent, right? So I know 1 is congruent to 2. 2 is congruent to 3. So I can say that angle 1 is congruent to angle 3. What reason is that, Julia? You can give me 1 of 2. You said what? Substitution's cool. Or transitive property would work as well too. All right, if you know that angle 1 is congruent to angle 3, what can you tell me? AB is congruent to what, Prabnor? CB, right? Yeah. What's up, Landon? You all right? Angle 3 is... We were looking at the wrong side. Womp womp. So I can say that AB... Dude, what just happened to all of that?
Got the undo button.
Hit the back arrow.
Where's the back arrow?
It's at the top.
No, but it's like it's gray.
It's grayed out.
It's just a glitch. It just does that.
Yeah, where it just wipes everything out.
Yeah.
We just saw it in real time. Sick. All right, so AB
Oh, you didn't do it, Kyle.
No, I
is congruent to CB.
1 and 3.
Normally, it's not a big deal when that glitch happens because you guys have everything written down. But unfortunately for these two guys, you looked at the other proof. All right, but either way, we need a reason for that, right? So we're going to say this. This is going to drive Dom nuts. Sorry, Dom. Converse isosceles base angles theorem. It won't even let me undo it. Yep. Converse of the isosceles base angles theorem. I know he's trying to cook up an abbreviation in his brain right now. He's zoned out. Never mind. I was just talking about how that's a long name for a theorem, and you're probably trying to think of an abbreviation for it.
It's not.
All right. So the theorem shouldn't be that bad. Okay. I mean, we could do it, right? Yeah. All right. Get working on your worksheet. I'm giving you guys time in class. You've got 22 minutes to get it done.
I think I'll finish it.
Yes. Let's see if you can get it done
Dude, all these proofs.
before you walk out my door, which I think you will.
But what about the